Angles and angle measures. That's what's in this lesson. Okay, so first, let's talk about what an angle is in standard position. When we say an angle is in standard position, right? Because if I told you to draw an angle, right? Like from geometry, let's say, you could draw an angle any which way. That's an angle. That's an angle. Okay, but we don't want our angles oriented in all sorts of weird, funky ways. We want our angles in the standard position, and an angle is in standard position if three things happen. The vertex is at the origin, so you can see here, the vertex is at the origin. The initial side is the positive x-axis. So look, I'm going to start drawing my angle. This is the first side I draw here, okay? That's my initial side, and it lies along the x-axis. And you get the terminal side by rotating from the initial side. So from that initial side, you rotate and you get your terminal side, okay? Now, once we put this on the x and y axis, then if we were here, if my initial side was here, okay, and I haven't opened up my angle yet, I have a 0 degree angle. So that's 0 degrees. Now, if I open it up until here, I have 90 degrees. If I open it up until here, that's a 180 degree angle. If I go a little bit more to here, that's a 270 degree angle. And if I go all the way, I have a 360 degree angle. All right, so that's how we label our axes.
You're able to do 360.
We are going to do 5040. We're going to do negative 5040. Yeah, that's the difference between, so in geometry, we only go up to 180 degrees because it's about triangles and, you know, that's about it. Here, we're going to, there is no limit. Yeah. We can rotate in two directions. We can go counterclockwise, which is against the direction of a clock. So, for example, if this is your initial side, you can start rotating this way. That's counterclockwise. In math or physics, counterclockwise is always considered the positive direction, and we call that a positive angle, okay, when you have a counterclockwise rotation. Or, so this is a positive angle, or if this is the terminal side, I can rotate clockwise this way, okay? And that gives me a negative angle. So negative angles result from the clockwise rotation. All right, so if you look here, this is the initial side. I rotate up counterclockwise 120 degrees, so that's a positive 120 degree angle. In the next one, this is the initial side. I rotate in the clockwise direction 145 degrees. That's a negative 145 degree angle. All right, so the negative sign is just the direction of that initial rotation. All right, so let's draw these angles in the standard position. We're gonna need our axes. Okay, all right, so the first one, 210, here is the initial side. It's positive 210, so I'm going to go clockwise. I'm sorry, counterclockwise. So look, 90 degrees, 180 degrees, a little bit more to 210 right there. That's 210 degrees. It doesn't have to be NASA precise, okay? But it does have to be in the correct quadrant, all right? Yeah.
Does it matter if you draw the line all the way across, or you always draw it from the center? The red line, the red arrow, is always drawn from the center?
Yeah.
Okay. Is each quadrant 90?
Yeah. Okay, so negative 40 degrees, here's the initial side. Negative 40, I'm going to go this way. That's, you know, less than halfway. Right there. So that's negative 40 degrees.
Are we required to draw the circle or like the angle?
The arrow, yes.
That's like Okay.
Yeah, so I know which way you've rotated.
So then what if it's like more than 360?
Then, yeah,
Then you have like an inner circle and a little bit of an.
you'll have a spiral. Yeah. Okay, so look at this one. This is 470. We start from here. Okay? So 470 means I'm going to go counterclockwise. 360, how much more to make 470? Another 110. So here's 90, 110 right there. Okay?
Does this slope, like, does it go inside or outside?
So
When it goes around again, does it go on the outside or the inside?
it's a spiral that just goes out.
Okay.
Wait, should we say 470 though? Or no?
Oh, yeah, sorry, it's 470. I'm sorry. Okay. So,
Can you explain again the difference, the terminal side and the initial side?
the initial side is the blue one, the first one. The
Yeah.
terminal side is that second one that you draw, the red one. The terminal, the ending.
Oh.
Initial side, terminal side.
Okay.
Okay, so here's an illustration. We're gonna draw the following angles in standard position on the same axes. So let me draw a set of axes. Okay, and first I wanna draw the 40 degrees. So that's my initial side. I go counterclockwise, and that's about 40 degrees, right? Yes? Now let's do the 400. So this is going to be the initial side. And I'm going to go 360. How much more do I go for 400? 40 more. What do you notice? It's the same exact angle. Same exact angle. So when angles are in standard position, they all have the same initial side. It's always along the x-axis. But when the angles have the same terminal side as well, we call them coterminal angles. Coterminal angles are two or more angles in standard position that share the same terminal side. Okay? Now, how do we find coterminal angles? We find coterminal angles by adding or subtracting any multiple of 360, okay? So this is how we find coterminal angles. All right? So basically, watch. If I have a 40-degree angle, okay, I'm here. All right, now, if I go around 360 degrees, I get to the same point. Now, if I go around 360 degrees again, I get to the same point. If I go 360 degrees in the negative direction, I get to the same point, okay? So whether I add 360 or subtract 360, I get to the same point, all right? So let's do a couple of examples. These are really a lot more straightforward than you might think. Okay, so here we need to find one positive and one negative angle that is coterminal. All right, so to find the positive one, I take 210 and I add to it 360 degrees. And what does that give me? 570. So that's the positive coterminal angle. To find the negative coterminal angle, I take 210 and I subtract 360 degrees. And what do I get?
Negative 150.
Negative 150. Okay? Now, I know it's common sense, but when I ask you for a positive coterminal angle, it actually has to be a positive number, and a negative has to be a negative number. Sometimes you subtract 360, but you still don't get a negative number. You have to keep subtracting until you actually get a physically negative number, all right? Let's do some more examples, and you'll see what I mean by that. Okay, so positive, for the second one, it's going to be negative 120 plus 360. How much would that be? 240 degrees. And then the negative negative 120 minus 360, negative 480 degrees. All right? Now, take a look at this next one. For the positive, let's do 580 plus 360, right? That'll give us a positive number. How much would that give us? 940 degrees, okay? And that's totally fine. It's a positive number, it's coterminal, it's totally fine. Okay, for the negative one, let's do 580 minus 360. What does that give you? 220. Is that enough? No, that is not a negative angle, right? So now I have to go one more time. 220 minus 360, how much is that? Negative 140. Now, that is my negative coterminal angle. Now, could I have completely skipped the first part in the purple and just done the one in the blue? Because look at the 220. What is that? That's also a positive coterminal angle. So I could have skipped the first line completely, started with the 580, subtract 360, because look, on my way to the negative coterminal angle, I came across another positive coterminal angle. All right? So I could have just skipped that first part, started with this. Okay, that's my positive, and then I go one more time and I get a negative.
There's really not like one right answer.
There is not one right answer. There are multiple coterminal angles. So both of these are positive coterminal angles. Okay. All right, so for D, that's what we're going to do. We're going to take negative 800. I'm going to add 360, and what do I get? Negative 440. Okay? Now, I do negative 440 plus 360. What do I get? Negative 80. And I do negative 80 plus 360. What do I get? 280. So now, which one of these is a positive coterminal angle? The 280 is the positive coterminal angle. Which one is the negative? Right? Any one of them, I can write any one of them as the negative. Okay? So this is a negative coterminal angle. All right? Yes?
In the coterminal box line on the page, it says adding, subtracting any multiple 360.
That means I can add or subtract one 360 or two 360s, right? Just like we're doing here. You can subtract 360 once or twice or 5 times, as many. Right. Right. Okay. Now, here we go. Yeah. Okay. So here we go. Radian measure. This is completely new. We've never seen this before. So, okay. Radian measure. Now, suppose you have a circle. All right? This circle here, this large circle here. Suppose you measure the length of the radius, and it turns out to be 10 meters. Okay? 10 meters. Now, let's make this imagine our school had a completely circular track field, right? Like a completely circular track. And you're out there and your coach gives you this job of measuring the radius of the track. Turns out it's exactly 10 meters. Okay? So now your coach says, all right, you're going to start here. He puts a pedometer on you. We all know what a pedometer is. It counts how many steps you take. It tells you what the distance that you've walked. And he says, all right, start walking along here. All right? And you have to walk the same distance as the radius. So how many meters are you going to walk? 10 meters. So you walk 10 meters. Okay? Well, the pedometer beeps. Okay? So you walk 10 meters, and suppose that length is now 10 meters. Okay, so you stop there. You draw a line from here to there. What have you just created? An angle. You've just created an angle. Okay? How did you create this angle? You created this angle by walking the same distance along the circle as the radius. Okay? So now this arc has the same length as the radius. When that happens, the angle that you've created has a measure of 1 radian. Okay? Alrighty? So that's what a radian is. 1 radian is the angle whose terminal side intercepts an arc with the same measure as that of the radius.
So you would never be asked for like the actual measure in meters of that angle?
No. No. So suppose you have another circle. That turned out to be a perfect circle and then it messed up. All right. So suppose the radius of this circle is 2 meters. Okay? How would you make an angle of 1 radian? How much do you walk? You walk 2 meters. Okay, so you walk 2 meters. So basically, if you take the ratio of the radius and the intercepted arc, it has to be 1. What happens to the units? They go away. That's why the radian has no units. Okay, the radian is unitless. Now, suppose you get carried away here and you just keep walking. Suppose you walk another 10 meters. Okay? Now you've walked a total of 20 meters. So the angle that you've created is this. How many radian is that? 2 radian. Okay? So 20 meters over 10 meters is 2 radian. Whoops. Yes, it can be a decimal. In fact, if you walk to this part, okay, if you walk here, okay, if you walk that distance, okay, and if you take the ratio of that over the radius, okay, so let's call this L over 10 meters, okay? So if you walk half the circle, that'll be, let's say, L meters. Over 10 meters, that is always the same ratio. You know how much that is? Anybody want to guess? Nope, it's 22/7. So you know how, like, when you walked until the 20 mark, it was 20/10, you got 2. If you walk until here, the fraction you get is always going to reduce to 22/7.
It's always pi.
What's 22/7?
Pi.
How many in decimal?
So when you get to half a
3.14.
circle, it's 22/7.
Yep. Okay, so that's what it is. So that's, well, pi is 3.14159 blah 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 blah. I know, I took it down. I was looking for it. It's actually 22/7. So the way they figured it out is they took a rate. They took circles of different sizes, and the circumference over the diameter, or this length over the radius of all of the circles turned out to be the same ratio, and it was 22/7. That's where pi comes from. So it's an irrational number. Oh, that's a whole other concept. Okay, so this is what radian is then. All right. So the distance that you walk divided by the radius gives you the angle measure in radian. Okay. Okay, so let's explore then. Okay, suppose you go a full rotation around the circle. You've just covered the circumference, right? How did we always measure circumference ever since we were like 9 or 10? Which formula? 2 pi r. So if you go around the whole circle, that's a circumference of, that's a length of 2 pi times the radius, 2 pi r. Okay? Now, we just said that this angle is the distance that you walk over the radius, right? So, huh? Okay, so we just said that if you want to make an angle here, if you want to figure out how big this angle is, what do? You take the distance that you walked over the radius, that's 1 radian. Now, if I walked the entire circle, that's 2 pi r, that's how much I walked. Over the radius, so what is my, what angle have I made? 2 pi. What does that mean? In radian, the angle around a full circle is 2 pi. Okay, so theta around a full circle is 2 pi. Okay? In degrees, how many degrees is it around a full circle? 360. So, if in radian it's 2 pi around a circle, and if it's 360 in degrees, that means 360 is equal to 2 pi. And if I divide both of those by 2, 180 is equal to pi. Okay? So pi is equal to 180. All right, so that's where that comes from. If there is anything you need to know, it's this, that 360 is the same as 2 pi. You guys have a question? The angle around a full circle is 360. In radian, it's 2 pi. If you divide both sides by 2, it's 180 corresponds to a pi. Now, those you have to take with you. You just have to know that, 180 and pi correspond because 360 and 2 pi correspond. So that is how you're going to convert between degrees and radians. There are all these, formulas here, blah, blah, blah. You're going to hear me saying this a lot in this chapter. Do not memorize that. Do not memorize that. That's why I go through this radian and degree in such great detail, because if you just know that the whole circle is 360 and 2 pi, half of it is 180 and pi, and that's your conversion. 180 and pi are the same. 180 and pi are the same. So let's write the degrees in radian here. Okay? You're going to do this the same way every single time. It's the same thing as you do in science. You're going to convert 30 degrees into radian times a fraction bar. Okay? Now, what is my conversion? Pi is the same as how many degrees? 180 degrees. That's all you're going to take with you. So look here. You have 30 degrees. Since the degrees is on top, it must go in the bottom here. And if 180 goes on the bottom, then pi has nowhere else to go but up here. All that's left for you to do is to simplify, and you get pi over 6. Okay? Let's do it one more time. You have degrees on top times a fraction. Where is the degree going to go? Where is the 180 going to go? Bottom. So pi must go on top. Simplifying this, 135 and 180, you can divide, how much would that be? And how much would it be? Okay, what else? And then, how much would that be? 3 over 4, so it's 3 pi over 4. Okay? All right, here we go. Whoa. Because if you do it by 360, then you have too much to, what happened here? Then you have too much to cancel. You'll see later. So here, it's again pi over 180. So we're going to reduce by what? By 8, by 6.
Yes.
So you get 40 over 30, which is what? 4 over third, so that's 4 pi over 3. Negative 270. Same business, huh? Yeah, 4 pi over 3, absolutely, nothing else. So we can, first of all, 1 0 goes away with 1 0, and 27 over 8 is by 9, negative 3 pi over 2. Okay? All right, now take a look at these. Again, times a fraction bar. This time, look, pi is on top, pi must go on the bottom, so 180 goes on top. All right? And so how much is this one? Pi's cancel out. The 3 and the 180 will give you 60, so this is negative 120 degrees. Okay? Right. Okay, so times pi over 180. Oh, sorry, 180 over pi. All right, the pi's go away. 6 with 180 gives me 30, so that's 210. All right? What about this one? Uh-huh. How many times? 45 times 11. 495. You guys know how to multiply by 11? Okay, we'll get to that later. Okay, pi over 2. Yeah, pi over 2. So that's going to be 180 over pi. And that's negative 90 degrees. Okay? Okay? All right. So, here we go. Fine. Okay, so here, we want to find one positive and one negative angle that is coterminal with the given angle. All right, so before we were adding and subtracting 360. Now we're going to add and subtract. What's the radian equivalent for 360? 2 pi. Okay, 2 pi. Another one? Why don't I give you this last page? Okay, so this is going to be plus 2 pi, right? For the positive one. Okay, so let me show you the quick way of doing this. There is a denominator of 3. There is going to be a denominator of 3 here. And now, look at what we do. When you have a fraction and a whole number, you multiply this way, so you get how much? 6 pi plus 2 pi, that's 8 pi. It works like a charm every single time. So that's the positive one. Let's do the negative one. Okay, let me do the negative one. 2 pi over 3 minus 2 pi, okay, is equal to, here is the denominator. Now here's what we're going to do. This times that is how much? Negative 6 pi plus this one, negative 4 pi over 3. Okay? So you're going to do it that way every single time.
So it's the same process for both ways, right?
Yep. Okay, let me do C first.
Do you always have to multiply first?
Yes, always first. Okay, let's do this one. Plus 2 pi will give me, it's over 2. Negative 6 pi plus 2. Okay, so here we're going to have 2 times 2, 4 pi plus 11 pi. That's 15 pi over 2. That's my positive coterminal angle. And let's do the negative one. 11 pi over 2 minus 2 pi. It's over 2, so it's going to be negative 4 plus 11, 7 pi over 2. Okay, that's not negative, so let's do it again. 7 pi over 2 minus 2 pi, negative 4 plus 7, 3 pi over 2. That's still not negative. Let's do it again. I feel like this is going to be the one, guys. Negative 4 pi plus 3 pi, negative pi over 2. And that is my negative 1. Okay? Yeah.
All the other positive answers, 3 pi over 2, they classify as the positive intervals.
They can. It's up to you which one you choose. Okay? All right. So let me quickly do this bottom formula, and then I will do the top one. All right. So we sort of touched on this. How, if you're given the radius of a circle and the angle, remember how we said, you know, the way to find the radian measure of the angle is to take the ratio of the arc length over the radius? Okay, so we call arc length S, okay? So if theta was that arc length over the radius, if I multiply both sides by r, what's S equal to? R times theta. So if you know the angle and the radius, you can find that arc length using the formula S equals R theta. Now, this is the process of how we find the radian angles, right? That means in order to be able to use this, your angle must be in radian. Theta in radian. I have to say, this is probably the most common mistake I will get on these problems. Otherwise, it's so straightforward. So, you have to find the arc length here. If the central angle measures 60 degrees and the radius is 9. Okay, so radius is 9 centimeters. Theta is 60 degrees. Is that usable for me? I have to multiply, I have to convert it pi over 180, and it ends up being pi over 3.
Why did you have to convert it?
Because my theta must be in radian to use this formula. Okay? So, S is equal to R theta. Now I can use this formula. So S is equal to R, 9 centimeters, times pi over 3. Okay? So this is 9 pi over 3 centimeters. It's really how much? 3 pi centimeters. Let's plug that in our calculator. So it's going to be 3, not times 3.14. You know you have a pi button here. So second and this caret, that's a pi button. That's the built-in pi. Okay? It's right above the fraction, the division button. That's 9.42 or 9.4. I will have specified. Let's go to 1 decimal place now, but you need to include units. So it's 9.4 centimeters. Okay? Now, this will be the homework for tomorrow. This was just an activity of you know, just showing you the patterns in the unit circle. We will do them tomorrow. Okay? You can do the homework without that.